Welcome to the today's topic. Today I'll discuss about problems related to applications of pattern growth approach that comes into the frequent item set mining. Myself Priyanka Gupta. I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. So I am going to cover the problems and examples related to the applications of frequent pattern mining growth approach. So why we need frequent pattern growth approach? So that is because of the we already have used the Apriori algorithm to find out the association rules, right? So for that we have mined about the frequent patterns, frequent item sets. So but there were the few drawbacks of that Apriori algorithm. So that is because of the two major shortcomings of the Apriori algorithm. First is the size of candidate item set could be extremely large. Suppose if we are having the huge data set, if we are having the large amount of data, and on that we are going to apply the Apriori algorithm. Okay, so in that we have to generate the candidate key. So for the larger data set, how many candidate key we have to make? So that will be the size of candidate will be the more in nature, so that we cannot use the a priori algorithm in that extreme purpose. Second is high cost. High cost on the computing support, since we have to scan the item set again and again on the database. So in the a priori algorithm, same database for the one element, one item set, we have to search for that particular item set again and again in that particular database. So if huge data set will be there, so searching time will be more and cost will be high, and as well as the we can say that more of the problem will be there. So to read of that, these are high cost and size of the candidate keys. Because of that, we are not using the a priori algorithm. We to overcome these of the challenges, the biggest breakthrough was the frequent pattern growth. So is that because here no candidate generation will be required. So suppose here no candidate generation will be there, so easily we have to search for the frequent pattern, and we have to construct that frequent pattern in the form of graphical representation, that is frequent pattern tree. So all the patterns, all the problems of a priori, that can be solved by the leveraging of the frequent pattern tree. So that's what we are using the frequent pattern growth tree exclusively, rather than we can use the a priori algorithm. So to be more specific, if I'll tell about more specific in nature, the item set size, that will not be a problem. So how what is the size will be there? Highest size will be there, but anymore, since all the data will be stored in a way in the compact version on the data warehouse. So there will be no problem if item set is more in item set size is more in nature. Moreover, if there is no need to scan the database over and over again, that's why we are using the frequent pattern growth tree. Instead of that, traversing the FP tree again and again, that could be the simplest thing to do more efficiently. So the same job more efficiently we can do, because here we don't have to waste time. The searching time we don't have to waste. Computational cost also will be decreased. Frequent pattern tree. What is the definition of frequent pattern tree? Frequent pattern tree is the core component of the whole frequent pattern growth algorithm. So that is a base of that particular frequent pattern algorithm. Because why we are going to apply, we have to depict it in the form of graphical representation, and on that we have to traverse again and again. So for each transaction, we have to make the FP tree. Then again, we have to traverse. Again, second item, if it will be there inconsequently, that we have to add there. Otherwise, the new branch will be added. So like this, we have to go through with the frequent pattern tree. Briefly speaking, if I'll tell, the FP tree is the compressed representation of the item set database. So that is a compact representations of the item set what we are having in the database. Next, the tree structure that not only going to reserve the item set in database, because if once we will use that particular item set, we are not going to use that again. But yes, we can traverse that item set in second scan. But also that is going to keep the track of the associations and the relationship between the item set. So we can get the correlations, we can get the relationship between the two item set or more than two item sets. So that will be the tree structure. On the basis of that, we can say, we can we can get the different associations and correlations. Next is the tree is constructed. After that, if we will apply the algorithm of the frequent pattern growth, then the tree depiction will be needed. So by taking each of the item set, we have to make the tree, and then we have to map it with the path what it is there for the one transaction. So in the tree, for the first time, we have to do one scan. We have to represent that particular frequent pattern tree. Again, in the second transaction, again we have to go from the null node, root node, and again we have to start and scan and check the another item set. So like this, the tree will be constructed. That will be the if the no any other item set will be there in after every transaction, so that will be called as a complete frequent pattern tree. So the whole idea of this was behind this construction is that the frequently occurring items that will have better chances of sharing the things, sharing the different items together. So if the one item has been occurred in one item set, the same item, if it is occurring in the other item set, so the branches, that particular item set, they have to share for the other transaction. So that on that basis, that is the branches is sharing the same items together. When we then going to mine the tree, because recursively in the nature, because for the each transaction we have to get the frequent pattern set. Now again, pattern growth, the name of the algorithm, is achieved by concatenating the frequent items patterns that will be generated from the conditional frequent pattern tree. So in the first scan, after that we will get the conditional frequent pattern tree. On the basis of that, each of the item set that will be concatenated, that will be merged with the other item set in the another transaction. So FP tree is the frequent pattern tree. Formally, we can say the FP tree is a tree structure. Tree structure look like pattern that will be defined below. What is this? Because one root level will be the as a node. So there will be the one root node. There will be the one root node that will be the purely in nature null. That will be null. So first we have to identify the rule. We have to identify the root of that particular items. Then we have to make it as a null, and then set of items again will be that will be carry forwarded. That will be added as a into the branches. So a set of item prefix subtree as a children to the node will be added, and a frequent item set header table will also be that will be instructed, that will be directed that particular frequent pattern tree. Second is each of the node in the item prefix subtree that is having the three fields. That is an important terminology about that. That is having the item name. So in the item name, that is going to register which item this node is going to represent. So that item name will be there. The item, suppose the branch, if A, B, C, D, E, suppose these are the few items are there. If suppose the branch starts from here to A, then A will be the item name. So there on the node we have to write the A. Next, count. So the number of transactions, how many times it is going to be occur, how many times from the all transaction, how many times the frequency is there, that will be written in there by the portion of the path reaching this node. So suppose the A has been reached 3 times from each transaction, so A colon 3 will be going to written. Next, it will be the node link. So what is node link? That is going to link to the next node. So suppose if A3 is there and next the D item is going to occur. So D and someone like item, if it is occurring for 1 time, so D1. So that will be the node link. So that will be the node link. That is going to be related, that is going to be that is going to be linked to the next node. So that will be the in the frequent pattern tree carrying the same item name are null if there is none. So suppose I have told about the one item, different item set. Suppose A is going to occur here 3 times. So in the next transaction, we have to show it as a A2. Again, A1. So 3 times we have to write the A3, A2 and A1 for the each of the levels. So that will be the node link. Next, for the each entry in the frequent item set header. So header table will be there, that is having the 2 fields. So what are the 2 fields are? First, it will having the item name. Second, it is having the head of the node link. That is going to point that the first node of the frequent pattern tree carrying the item name. So suppose I have told you A and head of the node link. So next link that will be there, that will be written like this, and that in the A2, A3. So like this we have to point out for the each of the head that is going to link for the second consecutive nodes. So the table will be having these of the two items over there. Next, we are going to take an example that is a problem of a given transactional database. So it is a small example, but for the larger example, we have to try the same thing. Same scanning will be there. Same of the we can say labels will be there. So the problem is there, given a transaction database DB and a minimum support threshold sigma, find all the frequent patterns item set that are item set with support no less than sigma. So here suppose minimum support we have set as a sigma is equal to 3. So below that any of the support, if below with that will be there, less than that will be there, we have to discard that. So the problem is that we have to take the minimum support of 3 item sets, or we can say frequent patterns. So here the given database is having the 5 transactions, that is TID, and item bots that is having the few items. So in the each transaction, the sum of the items is there in the bucket. So there are some items in the bucket. So this is basically a transactional type of database. What output we get from this? We get all the frequent patterns, like for example, there will be the F frequency, A will be there, FA will be there, FAC will be there, FAM, FM, AM. Like this, we have to find out all the frequent item sets from that particular database. Now, we are going to scan that transactional database. So the 2 main steps will be there for when we are going to construct a frequent pattern mining tree. So first step is we have to scan the transactional database. First we have to check the transactional database. Then for the first time we have to find out the frequent items. What are the frequent items are there? We can say if A is occurring again, so we have to roughly we have to count in mind. These are the frequent items are there in this particular database. But if larger data set is there, we have to make it through one by one. So for the first time, we have to find out the frequent items, that is single item patterns, single item sets, and order them into the list L, as that is how much frequency it is having for the each transactions. So we have to sort out it in the form of ascending order. So suppose the example, if L is equal to that in curly braces F colon 4, C colon 4, A colon 3, B colon 3, M colon 3, and P colon 3. So these are the items, and these are the items are there. These are the single items are there. Suppose 6 items are there, and this is the frequency to occurring. So F is occurring 4 times in that transactional database. C is occurring 4 times, A is occurring 3 times, B, M, and P is occurring 3 times. So in the format item name and support, we have to write, we have to arrange the things. Next, for each of the transaction, we have to order its frequent item sets according to the order in L. So what is the order in L? Like here the highest order is F, then C, then A, then B, then M, then P. So suppose in the second transaction, if there is a item A is there, then P is there, and then M is there. So it is not in the ascending order. So we have to arrange it as in this form. So that will be the A, M, and P, because M here comes first, P here comes second. So like this we have to arrange that format into the form of item name and support. So again when we will order that in the L, then we have to scan the database for the second time. So for the second time, if we will going to scan that, we have to start constructing our frequent pattern tree. How we are going to put the each frequency ordered transactions onto it. So for the first one transaction, we have to keep the things in suppose in the consecutive nature. Next, in the second scan, we have to check it again, and when it is occurring regularly, we have to add there. If it is not there, if some item is coming in between, so we have to make another branch related to particular that item set. So like this, we have to order that the particular frequent pattern tree. So here we will take the same example. So for the first scan, for the first step 1, we have to scan the database for the first time to generate that list L. So in that we can see this was the pure items what was bought in there for the total 5 transactions. So in that, what is the frequency of each item? So here we have taken the F, C, A, B, M, P. So that is occurring in the 4, 4, 3, 3, 3, 3. So below that, any other below that we have find out here the I item was there, G item were there, D item were there, and O item were there, L item were there. So we have already discarded that. So we will check here. So here the F is occurring here 1, 2, 3, and 4. So F is 4. Next A is 1, 2, 3. A is 3. Next C is 1, 2, 3, 4. So C is 4. D 1. D is occurring 1 time. G is also occurring 1 time. I is also occurring 1 time. M 1, 2, 3. M is occurring 3 times. P is occurring 2 times. P is occurring 3 times. Okay. So A, B we have not covered. B 1, 2, 3. So B is occurring 3 times. M we have covered. L, B, C we have covered. F we have covered, L we have not covered. So L 2 times. L we have covered. Now M we have covered, O we have covered. No, O we have not covered. So O is occurring 2 times. O is occurring 2 times. B, F, H. H we have not covered. So H is occurring 1 time only. H, J. J is occurring 1 time. So like this, if the here we can see the O support is 2, L support is 2, D, J, G, I, H. So these are the support that we have set support as a 3. They are less than that. So we need to discard these items. We don't need to carry forward these of the items. So we have to only keep those are the support which is greater than 3. So here all the items have been deleted. Only F, M, A, C, B and P will be there as in the list L. So like this, we have to first find out the frequency that is that comes under the condition frequency minimum support, and that is equal to a greater than 3. So we have arranged this list in this form, that is byproduct of first scan of database DB. Now in the second step, we have to scan the database for the second time. Now we have to order the frequent items in the each transaction. So here what we will do, here we have to arrange that the transaction ID were there as a class level, the item bought will be were there, and now we have to arrange the frequent items that is in the nature ordered. We have to order that in the ascending. So now that is the actual database that we're having in the actual database DB. Now we are arranging the frequent items here. So what are the frequent items here? So already here, if we will see, D has been discarded, I has been discarded, G has been discarded, only F, A, C, M, P is there. But in the what were the frequency over there? That is the highest frequency. In that order, we have to rearrange that. So F that comes first, F, then C. So here A is there, but we don't have to write A, we have to write C. So because that is a maximum frequency. Next A, next M, next P. So like that, we have to order that particular list. In that second transaction, that is T2, in that we have to check for the what are the items has been discarded. So B is there, C is there, F is there, L has been discarded, M, O has been discarded. So the ordered will be there, F, C, A, B, M. That is coming as a highest support count. Next, in the T3 transaction, that is having the 300, in that B, F, H, J, O. So J will be discarded, O will be discarded, H will be discarded. So BF. So BF will be there, but first F comes first as it is having the frequency 4. So that will be the FP in the list. Then again, in the fourth transaction, we are having the B, C, K, S, P. So again, we have to arrange these of the items as a C, B, P, because K is not there, S is not there. So we have to rearrange in the ordered list on the basis of frequency. In the fifth transaction, that is T5, we are having these of the many items over there, but E we don't need, L we don't need, N we don't need. So these are the 5 items we need, but we have arranged it as a F, C, A, M, P. So this is the final frequent items that is being ordered on the basis of frequency. What is the frequency in that particular database DB? So this was the second scan of the database DB. Next, we have to construct the FP tree. So now we are here we have to take the null node. So here we have taken that is a null node, that is going to be depicted as a curly braces. So that is a null node. In that first transaction we are having the F, C, A, M, P in the curly braces. These are the items we are having in first transaction. So how we have to arrange that? Let's see. So here that is the null node, right? So here we have to keep null node. Next item is F. So F that has been occurred 1 time. So F1, again C1. So we will write C1, node will be there, rectangular box will be there. In that we have to write it as that is the item, and that is a column that is representing the frequency of the item, how many times it has been occur. Next we have to add the A1, then we have to add the MP, M and P. So these all having the one frequency. Next, now that item has been that item is we have to arrange in that order again. If suppose the order is of the item is FCABM, in the second order we are having the item FCABM. So how we have to add this? So here F occurred again, so F became 2. Here F was 1. Here F was 1, that has become 2. So that will be null node will be same. So in this we only have to showing these of the every step for to understand these of the transactions. So we have to add the F2 node. F and 2 times it has been occurred 2. Again C again second time it is occurring C2. A, it is again occurring A2. Okay. Now B. So here B came because A were there and M were there, but it came in between B. So how to connect that? We have to connect it is another new branch. So M and P will be there like same, but we have to add it with the A2 in the right hand side, as a box will be there B and frequency is 1. Now the M has been occurred, but what was the frequency? Because M already has been completed here, but in this transaction we cannot add this M in between, because after A the B has been occurred, but already M is there, so there will be the we can say kiosk. So now we have to add it M as a new branch with the B. So that will be the M1, but we have to connect it with the first occurred M1. So that will be the dotted line that will connect to that M1. So here one time, here one time. So we have not to write again and again, because here it is counting as a 1, and in this branch it is counting as a 1. So for this transaction, second transaction, that all the items has been added like this. Now, in the next transaction, we have to again construct the next transaction tree. So again, in this list, FB is there. So F, that is occurring again, but that is a starting element. So we have to add it in a F3 nature, and rest of the tree will be same as earlier. Now the B is occurring, but in the earlier transaction, tree that was not there, that is a new node, so that will be connected with the F in the right hand side. That will be the B, that is 1 time it is occurring. Next, yes, so that has been occurred actually in second transaction as a B1, but we cannot add that there. So what we have to do in the first transaction dotted line, that will be connect to this current transaction. So this earlier transaction that will be depicted as same as earlier. So like this, that third transaction has been completed as a FP tree. In the next transaction, CBP. Now we have to add CBP. So what we have to do, the earlier tree that will be same as earlier. Now we have to add the new items, new branches. So C. So C is already that has been occur, but that is not connecting with the F, that is starting from the C. So we have to add this with the null node. So that will be the branch of null node, that will be in the right hand side. We have to write C1. Now B. So again we cannot add B over there in the first transaction. So B, that will be added to this, and that will be the dotted line from the B1, that will be adding with that B1, the current B1. Next is P1. So that will also be connected consequently. That will be the P1. So all the P1 is occurred in the first transaction. So that will be added from the first node. So like that will be the node link. That will be the node link of that particular third transaction. So like this, we have added the 3 items from the fourth transaction. Now in the fifth and the last transaction, that is having the FCAMP. So now, in that F is occurred again. So we have to add here in the first node F has been that has been became 4. Earlier it was 3. C because C already that has been that has been created earlier. But now what we have to do, we have to add that C in the consecutive nature, because F is occurring in the second time. So the node that C3 that has been occurred here again, so in the consecutively with the F, so F will be increased with the 1, that will be the F3, that will be become F4. Next item that has become C3. Next item that is A, that will become 3. Next item M, that will become 2. P, that will become 2. So we don't have to add again one particular branches, because that is the same order that we have having in the first transaction. So like this, then the complete tree, the complete FP tree we have found. We have found the FP tree of the all the transactions of the that particular database. Now that is a final FP tree we are having here in the right hand side, but we have to we have to connect it with the header table. So in the header table, what will be there? The items will be there and heads will be there. So all the items has been written over here, FCABMP. So this is the first order, that is the order according to the frequency of the support. So now from here, the dotted line that will be added to the each of the connected first transaction elements. So that will be added. So B is not there in the first transaction, so that will be added into the second transaction B. Second transactions B. So that is the final FP tree here with the header table. Now suppose in another example we are having, suppose why we are using the descending order. Why we are having the descending order? So we have taken another we can say transaction database. So here in this transactional database, 2 of the transactions are there, that is having the T1 T2, that is having the T1 T2 transactions. So that are having the unordered items, that are having the unordered, so that has not having the frequency ordered items, support ordered items. So that has been kept as same as earlier. So here the same items are there, but they are not ordered. So here FACMP, AFCPM. So how we are going to construct the FP tree for that? Let's see. So here in the we have to take the null node, right? We have to take the null node for the first transaction, that is having the FACMP. So simply we have to write the F one time, A one time, C one time, connecting noded, M one time and P one time. So that the first transaction has been completed. Now in the second transaction we are having the AFC. So it is starting from the A. It is starting from the A, but the tree that we have depicted into the from the first transaction, that will not have any use of that. Now what we have to do, we have to construct a new branches from the root node having these of the 5 items as individual. So now we have to add the A1, F1, C1, P1, M1. So what is the use of this tree? What is the use of this tree? So on that basis we can understand the use of that frequency table, and we are having the ordering of the frequent items, and how we are going to beautifully use that particular branches over the each transaction. So that is that is a difference between why we are not using the ascending order items. Why we are using the descending orders, ascending order items. Why we are not using the descending order items? So that is not a correct frequent pattern tree. Again, we will take another example, second example, why that ascended order is needed. Why the ascended order is needed. So again, we are having a transactional database DB that is having the 5 transactions, that is having few items, that is unordered, that is ascended, that is having the PMACF. So because we are not using the ascending order items, here they all have been ordered into the ascending order. So here what we will do, if we are going to construct the frequent pattern tree, so the item, the null will be there, null node will be there. The item P we have to add first, then we have to add M, A, C, F. So like this we have completed one transaction. Again MBA. Now, so second example is there. Here we are, if we are going to use the ascending order of items, so in that transactional database, we are having the 5 transactions T1, T2, T3, T4 and T5. Okay, and we are having the frequent items in ascending order. So they are having the some items, same items, but that is having in the ascending order. Now we have to construct a frequent pattern tree. So there will be the null node, right? So again we have to add the P branch. So P will be 1, M will be 1. Here I'll depict P, that is a null node. That is a null node. Again that P node will be there, P1. There will be the M node, one time. There will be the A node, one time. There will be the C node, one time, and there will be the F node, one time. Right? So for the one transaction, that all the items has been completed. Now in the transaction T2, we are having a M item. So M is not starting from here. That will be added from here. So M will be 1. B again, that will be added here, B1, because there is no any we can say any relationship between the that transactions. A will be there 1, C will be there 1, and F will be there 1. So 2 of the transaction has been completed. Now next BF. So now BF. So what we have to do? BF. So here we also have to add the BF. So the BF is not there, that has been not starting from anywhere. So what we will do? We have to check the B1. So there is in second transaction we are having the B1, right? So in that we cannot add that element, but we have to add that element as a third item. So that will be the B, and there will be the F at the one time. There will be the in the fourth transaction T4, that 3 items are there, PBF, PBC. So next we have to add the PBF. So PBF we have to add. So again we have to add that particular item. So after adding all items and arranging the things in the last transaction, and the same items are there, so that will be the P3, because in the fourth transaction that is starting from 3, so that will be 2. B is there, B is not there, so we have to add B here, B1. C is there, again we have to add the C1. In the last transaction, P is starting from here, so P will be 3. M will be 2. A will be 2. C2, F2. So that is the final list of that particular transaction. So this is a final FP tree. So this tree will be larger than the FP tree, because in the FP tree more of the frequent item has a higher position. So on order of the frequency, that all will be arranged. All the items will be arranged if that is having the descending order. That is according to the frequency of item. So which makes the branches less. Here we are getting the more branches. We are having the 3 branches. We are having the again extended branches from that. So we don't need this type of frequent pattern tree. So because that we are not using the ascending order of ascending order of frequent patterns. So we have to construct the FP tree from a transaction database. So here the ordered frequent items are there. That is actually a same what example we have taken in the first. That is the same example, but in one we can say one slide we can understand that. So for what we have to do, we have to scan the database once. We have to find out the frequent one item set that is having the single items over there. So we have to make the frequency table. We have to sort that frequent item into the order of frequency of that descending order. So in the F list, we have to make that items as a regular items, that is a frequent items. So that order will be there in the F list. That will be the F, C, A, B, and P. So these are the frequency because 4, 4, 3, 3, 3, 3. So 3, 4 times. So like this, the F list will be there. Again, we have to scan the database. We have to construct the FP tree. So on the basis of the minimum support, all the rest of the items has been discarded. Now we have to make the header table. On that, item will be there, frequency will be there, and head will be there. So here all the items frequent, all the individual items will be there, single items will be there, frequency will be there, and rest the head will be there. So from this head we have to add this every item. If that is not in the one transaction, we have to go with the other transaction item. So like this, the FP tree will be completed. So find the patterns having P from the P conditional database. So here we have to start at the frequent item header table and the frequent pattern tree. So we have to first we have to arrange the header table. So what is having the frequent item sets? We have to change that frequent pattern tree by following the link of each frequent item P. We have to accumulate all the transform prefix paths of item P from the P's conditional pattern base. So here in this example, we can see this is the same header table we are having. There is a this is a FP tree that we were having from the that particular transactions, but we are having the conditional pattern basis that is having the item. So here what we have done, we have just traversed that, we have just achieved that pattern. So that has been started from the C, that has been started from A. So excluding this C, A, that is B, because B came here with this branch. So B, the M, then P. So like this, the traversing will be there. So what is the count is there for this particular item? So F on the basis of F, the items conditional item, what is the connecting node is there? So that is F, right? So on the basis of F, we have to exclude that F, and on the basis of that, we have to check the other items. So what is connected to the F? So F is connecting to C, right? So F is connecting to C, that is having the frequency of 3 times. A is connecting to FC. A is connecting to FC. So A is connecting to F is also there, and C is also there. So F is connecting 2 times. So 3 times. Here also it is there. So 3 times. B is connecting FCA. FCA is this is actually reaching the that particular node. What is the items is coming in between that we have to take. So FC3. So that is particularly FC3. FCA, that is 1 time, F 1 time, C 1 time for that particular one branch. Because for B, for M, FCA, and for M, FCAB. So reaching to this M, what is the frequency of FCA? P, for P, FCAM. So this is the one root, and CB. So that is the CB. So what is CB? CB. So reaching this P, that is another frequency, that is 1 time. So like this, we have to understand that conditional pattern base. So that is nothing but the what is the total way to reaching that particular item. Next, from conditional pattern bases to conditional frequent pattern tree. So for each pattern base, we have to accumulate the count for each items in the base. We have to construct the frequent pattern tree for the frequent items of the pattern base. Now this is the same frequency table, header table. Now here that FP tree. Now we have to add the conditional FP tree. So what is the way? For the M items, for the frequent items that is relating to M, so that is relating to M, so that the path will be there FCAM, FCA, so that is a 1 time, to M FCABM, that is a second, to reaching to M. So these are the two paths over there that is starting from the F. But that is telling us to F3. So because this and this. So with F1, with CM and M1. So these are the three paths there with that is starting from that particular node. C3. So C3 means FCM, FCAM, SCAM. So these are the three. FCAM. So that is having A. So that is having the 3 times. So that is a conditional FP tree. So the conditional pattern tree, we have to show it like this. So here we are having the recursion of mining each of the conditional FP tree. So the base will be there for M conditional FP tree. The null node will be there. Then frequency of F will be there. C will be there, A will be there. So these are the three items that is occurring while we are reaching for the A. Like this, the continuate pattern base of AM will be there, FC3. So AM for FC3, this is FC3. So continued pattern base for CM, that will be F3. So this is F3. Continued pattern base of that F3 will be there. That will be depicts like this. That will be depicts like this. That will be depicts like this. So these are the mining of the each conditional frequent pattern tree. So that was all related to the problem on applications on frequent pattern growth approach. One special case is also there, in that the single prefix path will be there for the FP tree, frequency pattern tree. So suppose a conditional FP tree is there, right? That is having the name T, that is having a shared single prefix path. So the prefix path will be there like this. This is a special conditional FP tree is there. So mining can be decomposed into the two parts. We can also write this. We can also draw this conditional frequent pattern tree in the other form. So what we have to do? We have to decompose this into the two parts. We have to reduct that single prefix path into the one node. Then we have to concatenate that the mining results of the two parts. So here we can see in we have to store that in R1 is equal to A. So that upper part will be written like this, and plus the second part in the below that has been written like this. That will be added with that R1. So that is a special case. We can write the conditional FP tree. So that was all about the today's class. In that we have covered the how we are going to make a frequent pattern based growth based tree. What are the different terminology related to that? How we are going to depict that? What is the important cases are there? What are the conditions are there? Because in that we have to do it in the descending order. We cannot use it in the ascending order. We cannot use that in the if the descending order will not be there. If any other order will be there, that will be mess of that FP tree. And again we have covered the conditional frequent pattern tree also. On that we are having the special cases. If the one branch is there, is a single one branch will be there in the left hand side or right hand side, that is unbalancing the tree. So we have to draw that frequent tree in the two parts. So we have to add concatenate that two of the parted into one part. So that was all about the problems related to the frequent pattern based growth tree, frequent tree. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.